Hello students, my name is Shashank Shekhar. So today we will do the exercise of haloalkene and haloarene. So the first question says that write the IUPAC name of the following compounds. Okay, so we have to write the IUPAC name of this compound. Let us see the first compound here. So we have CH3, CH, CH3, C, CH3. If I just write it here, so we have CH3, CH, 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 C, and CH3. Here we have again CH3, and on the downside we have CH3. So this is our complete structure. So while naming a compound, the first target is to find the longest chain. So if you look here, so this one is the longest chain. Okay, so this one is the longest chain. Next, if we start numbering those, so where we will number it from left or from right. So from the left side, we have the one substituent. Okay, we have one substituent, but from the right side, we have two substituents on the second position. Therefore, we'll try to number it from this side. So 1, 2, 3, 4, 5. Now, what are the substituents that we have? On 2 position, we have methyl, 2 methyls, and on 4th position, we have one more methyl. So I will write it as 2, 2, 4, trimethyl. 3 methyls are there. So trimethyl. How many carbons? 5 carbons. So pent. And on the 3rd position, we have alcohol. So pent 3-ol. So 2, 2, 4, trimethyl pent 2-ol. Next question. How many carbons are there? 1, 2, 3, 4, 5, 6, 7 carbons. Okay. So 1, 2, 3, 4, 5, 6, and 7 carbons. We have C2H5 here, OH here, and one more OH on this side. So of course, the longest chain will be this one. So this will be the longest chain. Now if we start numbering it, so we'll number it from the left side. Why? Because OH group comes first. So 1, 2, 3, 4, 5, 6, and 7. Now on the second position we have ol, on 4th position we have alcohol, and the 5th position we have ethyl. So 5-ethyl, hept 2,4-diol, 2,4-diol. At 2 position we have alcohol, and 4th position we have alcohol. 2 alcohol, so di, and then ol. So 5-ethyl hept 2,4-diol. Third question, CH3, CH, CH3. Okay, CH3, CH, CH, and CH3. We have OH here, and again we have OH here. Now if you number it from either side, since it is symmetrical, and this is the longest chain and the only chain that is available. Now 1, 2, 3, 4. So on 2 and 3rd position we have alcohol, 4 carbons, so butane, 2,3-diol. So this is the name. Next we have this structure. Okay, this one is the longest chain. Next, we have to number it. So 1, 2, 3. Three carbons are there. So methane, ethane, propane. Propane, 1, 2, 3, triol. Fifth question, this compound, easy to handle. This is a compound, okay? So if I number it from here, so first, second, third, fourth, fifth, and sixth. So what will be the name? Say. Okay, so what we do is we name this compound as phenol. Okay, so as a derivative of phenol, I'm naming it as a derivative of phenol. At second position, we have methyl. So 2-methyl phenol. 2-methyl phenol. Clear? Or we can also write this as orthomethyl phenol. Okay, orthomethyl phenol. Next is similar to that, we can name it as paramethyl phenol. What about this? This is orthopara dimethyl phenol. Orthopara dimethyl phenol. This one, so this one we can name it as 1, 2, 3, 4, 5. So what I'm doing is naming it from the number side. So 1, 2, 3, 4, 5, 6. 2, 6 dimethyl phenol. Or if you don't want to name it as phenol, just name it as paramethyl. Okay, paramethyl benzene ol. Okay, so I think this would be more appropriate as a derivative of phenol. After this, what we have? So what you will give? What will be the name of this? So this is ethoxy. Okay, ethoxy. 3 carbons. So pentane, pent, or you would how you would name this one? This part you will name it as 2-methyl pentane. Okay, ethoxy 2-methyl pentane. What about this? This is ethoxy benzene. Sorry, this is not ethoxy. This is methoxy because 1 carbon is there. So methoxy 2-methyl benzene. This is what? This is ethoxy benzene. What about this? So it is C7H15. 7 to the 14, 115. So I think this is written wrong. Okay, so we'll see it. Okay, so which one is correct? We will see it. Next, what about this? This is also ethoxy 1-methyl propane. This is also 2-methyl propane. So what we do in the naming of ether is we take the shortest one. Okay. After taking the shortest one, we will name the longest one individually. So we have, if you just keep this thing aside, so what will be its name? So its name will be 2-methyl propane. And this 2-methyl propane, it is methoxy 2-methyl propane. Okay. Similarly, this is ethoxy 1-methyl propane, and you will do the numbering from this side where the oxygen is attached always. Okay, clear? So let us see the name. So 2,2,4-methyl pentane, 5-ethyl 2,4-diol, butane 2,3-diol. This is 2-methyl-phenol. They have taken it as phenol, and rather than ortho and para, we have written it as 2-methyl. So we have written ortho-methyl-phenol. You can write it as 2-methyl-phenol also. This was propane 2,3-1,2,3-triol. Correct. This is 4-methylphenol. This is 2,5-dimethylphenol, 2,6-dimethylphenol. This one is 1-methoxy 2-methylpropane. So this one I have done wrong. So it should be like this. So I have written it methoxy 2-methylpropane. So I have written this thing earlier. You should also have a dash sign. Okay, so this is very important. These small things are very important. It can result in reduction of number. This one is ethoxybenzene. We have seen this. This one is 1-phenoxyheptane. Okay. This is 2-ethoxybutane. So the structure we were confused in was this compound. Okay, it was 1-phenoxyheptane. Next we have 2-ethoxybutane. So we are done with the first question. Second question. So we have to write the structure or whose IUPAC name are given. The first name is 2-methylbutane 2-ol. 2-methyl butane 2-ol. Okay. So first of all, butane, therefore 4 carbons, 1, 2, 3, 4. At second position, we have alcohol. And at second position, we have methyl also. So this will be the formula. Clear? Next is 1-methylpropane 2-ol. 1-methylpropane 2-ol. 1-phenyl, not methyl. 1-phenyl. 1-phenyl propane 2-ol. So first of all, we'll write the longest chain or the basic chain structure. So propane, therefore 3 carbons. 1, 2, 3. At first position, we have phenyl. Yeah. At second position, we have an alcohol. See, propane 2-ol. Here CH2, here H, and here CH3. So, will be the structure. Next is 3,5-dimethylhexane. 3,5-dimethylhexane. 1,3,5-diol. So the basic structure is hexane. So first of all, 6 carbons. Next, at third position, we have methyl. So 1, 2, 3. Suppose I am naming it from left to right. So 1, 2, 3. 3, and then we have one 5. Here, at first position, we have alcohol. This will be triol and not diol. So here will be alcohol. Here will be alcohol. And again, here will be an alcohol group. This will be CH2, CH. Its octet is complete. Here also CH, and this one is CH3. Okay, CH2 will be here. Yeah, CH2 will be here. So this will be the structure. Next is 2,3-diethylphenol. 2,3-diethylphenol. How we will name it? First of all, we will write the phenol. At second position, we have ethyl. And at third position, we have also ethyl. So this will be 2,3 diethyl phenol. Next question. 1-ethoxypropane. So C2H5 is attached here. 1-ethoxy and here propane. So C3 2 just 6. Okay, C2 just 6, 7, 8. So it will be 7 only. C3H7. So this is what? This is 1-ethoxypropane. Next one we have 2-ethoxy-3-methylpentane. 2-ethoxy-3-methylpentane. Again C2H5, then pentanes of 5 carbons. At third position we have methyl. So if we just name it from this side only, always 3 position. Okay, so this is methyl. Yes, 3. Next we have cyclohexyl methanol. Okay, cyclohexyl methanol means there is only one carbon in which OH is attached and in which hexane is also attached. Here H and here H. So this is what? This is cyclohexyl methanol. After that, we have cyclopent 3-in-1-ol. Cyclopent 3-in and 1-ol. First of all, cyclopentane. Suppose I'm taking this one as number 1. So this is OH and 1, 2, 3. At third position, we have a double bond. Okay. After that, we have 3-cyclohexyl pentane 3-ol. 3-cyclohexyl pentane 3-ol. So first of all, I will write the basic framework, that is pentane. So 1, 2, 3, 4, 5. At third position, we have a cyclohexane ring. And at third position, we have alcohol also. These are the rest of the remaining hydrogens. 10th question, 4-chloro 3-ethyl. 4-chloro 3-ethyl. 3-ethyl butane 1-ol. This is the name? Yes. So butane, so 4 carbons. First position we have alcohol, so OH here. Third position we have ethyl, so C2H5 here. And fourth we have a chlorine, so CH2Cl. Here H, here H2, and here what? H2 again. These are the structures. We can just match it. So, third question, Draw the structure of all isomeric alcohol of molecular formula C5H12 and give their UPSC name. So we have to draw the possible structure from the formula C5H12O. C5H12O. So for these kind of questions, what do? We first of all find the degree of unsaturation. What do? We find the degree of unsaturation. So how do we do it? Anyone remembers this formula? Just you can just write it. Okay. So I'm writing this formula. This formula is degree of unsaturation. This is given as 2 carbon, 2 into number of carbons. So 5 carbons are there, so 2 into 5. Then 2, okay, plus 2 minus plus number of nitrogen. So nitrogen is 0 minus number of X. Okay, minus number of X. Clear? Minus number of X. Oxygen we have to ignore. Clear? And hydrogen will be subtracted. So 12 hydrogen, this will be subtracted. Divided by 2. If I just write the complete formula, this is 2 carbon plus 2 plus nitrogen minus H minus X divided by 2, where X is what? X is number of halogen. H is hydrogen, N is nitrogen. This is degree of unsaturation. I am representing it as DU. Oxygen we have to ignore. Clear? We don't have to see for oxygens. We just calculate it. So 2 5 is 10. 10 plus 2, 12. 12 minus 2, 0. Okay? And this degree of unsaturation is 0. Means there is no double bond. Clear? There is no double bond throughout the structure. Which means that there is no ring or no double bond. So if degree of unsaturation is 0, so I am writing it, no double bond, double or triple bond, and no ring is present. So these two things are, you can say, analyzed from the degree of unsaturation. Here. So let us now try to write the structure. So 5 carbons, I'm writing it directly. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Then what we have? 12 hydrogens. CH3, CH2, 2, 2, and CH2, OH. So this is having 12 hydrogen. See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 hydrogen. So this is one of the structure that is possible. Next structure can be OH here. Okay. Then CH2, CH2, and CH3. First one. First one. Second one. What about third one? Just keep this OH in between. Keep this OH is between. So with this skeleton structure, with the linear skeleton structure, these three structures are possible. Okay. First here, second here, and third here. Now let us try a different skeletal structure, but it should not have a double bond or triple bond. So we have 5 carbons now. 5 carbons. So 1, 2, 3, 4. Suppose I place it here, 5 carbons. Okay. Now just try to place the alcohol. Suppose I am placing first alcohol here. This is CH3, this is H, this is H2, and this is H3. Now this OH can be here and here. Both will have the equivalent position. So I am placing on this carbon. OH. This will be CH3 and CH3. Next two carbons that are possible are this and this. So CH3, CHOH. Here it will be C, H, CH3, CH3. And one more structure that is possible is this one. CH2. Okay, CH2, CH, CH3 and CH3. So from this skeletal structure, these four are possible. Next, again 5 carbons. So 5 carbons can be placed in this way also. If you just place this carbon here, we can have one more structure. See? Now just place the alcohol CH2OH, H2, H, H2, H3, and H3. One of the structure is this. 1, 2, 3, 4, 5, 6, 7. 7 structures we have drawn. This is the 8th one. Now again, using this basic skeletal structure, we can have how many positions of our alcohol? Let us see. So I think I have done this wrong. We have 5 carbons only. I have placed 6 carbons here. See? 1, 2, 3, 4, 5, 6. What else can be drawn? So this can be drawn. Yes, this can be drawn. Suppose I am playing CH3 here, placing here this one, and this one. So this is the only structure we can have. The rest of all the equivalent structure, suppose you place it here, here, or here, they will result in the same, you can say same structure. Okay, they will be equivalent. Next, what we can have, next skeletal structure which is possible. 8 we have already drawn. Okay, 8 are already drawn. So with 5 carbons, so let me just try it. 1, 2, 3. This one is already drawn. 2, 3, 4, 5. A. Okay, so I think 8 structure are max. If you write the IUPAC name, I'm writing it quickly. So this one is simple pentane, 1 ol. This one is pentane, 2 ol. This one is pentane, 3 ol. What about this? Say 1, 2, 3, 4. 4 carbons. And 1, 2, 3, 4 carbons. At 2 position we have methyl. So 2 methyl. Okay, writing its name here. 2 methyl butane, butanol. It is at first position, so I'm not writing 1 ol. Okay. What about this? 1, 2, 3, 4. 4 carbons are there. But in this case, alcohol is on second position. So 2-methyl butane 2. What about this? 1, 2, 3, 4. So it should be named from this side, not from this side. Okay, from this side we'll name it. So what will be its name? Okay, so 2. At third position we have methyl. So 3-methyl butane 2-ol. Okay, clear? What about this? 1, 2, 3, 4. So its name will be 3-methyl butanol. Okay, at first position we have alcohol. So I'm writing it just as butanol. What about this? 1, 2, 3 carbons and 2 methyl substituents. So 2 dimethyl propanol. So these are the 8 structures and their IUPAC name. Now if I classify them as primary, secondary and tertiary, suppose I'm writing it with this pen. So this one is how much? This is 1 degree. This is 1 degree. Okay, this is 1 degree. What about this? This is also 1 degree. This is 3 degree. Okay. This one is 1 degree again. What about this? This is 2 degree. 1 degree. 2 degree and 2 degree. This question is done. Classify the isomers of alcohol. So pentane 1-ol, 2-methyl, 3, 4, 5, 6, 7 and 8 structures are possible. Okay, 8 structures are possible. So they have also drawn 8 structures. Now next we have classified them. Okay, so this is the question done. This question is done. Explain why propane has higher boiling point than that of hydrocarbon, that is butane. So the answer is very simple. Since propanol is having hydrogen bonding due to the presence of OH group, therefore it has a higher boiling point as compared to butane, which has no OH group present. So see, it has been drawn here. The interaction is shown here. This and this. Okay. On the other hand, butane does not have any such hydrogen bonding. For this reason, propanol has a higher boiling point. Now, because they have a hydrogen bonding, so they will require more energy to break through the bulk and go into the vapor phase. Next, we have alcohols are comparatively more soluble in water than hydrocarbons of comparable molecular mass. So again, same reason will be here also, due to the formation of hydrogen bonding between alcohol. So this is alcohol and this is water. You can see there is a hydrogen bonding interaction. For that reason, we have a higher boiling point as compared to normal hydrocarbon. What is meant by hydroboration oxidation? So in hydroboration oxidation, what do? We treat our say alkene with a borane, and the addition takes place in opposite to Markovnikov, that is anti-Markovnikov rule. At last we just hydrolyze it to get the alcohol. So the addition of boron followed by oxidation is called as hydroboration oxidation. For example, propane 1-ol is produced by the hydroboration reaction of propene. Okay, in this reaction we react it with diborane to produce trialkyl boron as an addition product, and then this addition product is oxidized to alcohol by hydrogen peroxide. See, now BH2 goes on this carbon rather than this carbon. Okay, so it moves to this carbon Now this boron has 2 hydrogens more. Slowly, all hydrogens are removed and it results in triborane. Okay, so this is the triborane C with one boron, 3 groups are attached. At last, we just oxidize this to get propane 1 ore. Clear? So if you have done it with say addition of water through acidic character, then it would have resulted in secondary alcohol. Okay, not in primary alcohol as we see here. After that, give the structure and IUPAC names of monohydric phenols of molecular formula C7H10O. C7H8O. Again, first find the degree of unsaturation. So I'm writing it as Du, 2 into number of carbons. So 2 7s are 14. Plus hydrogens plus 2 minus hydrogens. No nitrogens are present, oxygen is neglected. So minus hydrogen, that is 8. So 14 to the 28. 28 plus 2, 30. 30 minus 8 is what? 30 minus 8 is 22. 22 divided by 2, it is 11. So 11 is the degree of unsaturation. Clear? Again, let us see. So 2 into 7, 14, right? 14 plus 2, 28 plus 2, 30. 30 minus 8, 22. 22 by 2, 11. So since it is a phenol, so it will, of course, it will have a ring. So it is given a monohydric phenol. Next thing that is written is, next thing we have what? Next thing we have double bonds. So how many double bonds are there? 3 double bonds. 1, 2, 3, 4, 5, 6. So is this right? We have C7H8. Okay, C7H8. 6 are here. Clear? Then there is a carbon attached to it. Okay, there is a carbon attached to it, and since it is a monohydric alcohol, so we will have OH also simultaneously. Clear? How many hydrogens has been used? 6 hydrogen has been used and 1 hydrogen is being left. So how will name it? Say, so can we name it in this way? CH2OH. Clear? CH2OH. Right? Okay, so we have done here wrong. 7. 7 2 is 14. Now it is good. 14 plus 2, 16. 16 minus 8. 16 minus 8, 8. 2 minus 16 minus 8, 8. 8 by 4, it's 2. Sorry, 4. 8 by 2 is 4. So yes, now it is correct. So 1 ring and 3 double bonds. So this is the structure of the monohydric alcohol having molecular formula C7H8O. Now what is the IUPAC name of this? Say. So if I just name in this way, 1-phenoxy, 1-phenoxy, methane, methanol, 1-phenoxy, methanol. Okay, clear? So we can name it in this way, right? Or else we can name it in this way. Methyl, 1-methyl. Okay, no, this is correct. Okay, 1-phenyl, methanol, 1-phenoxy, methanol. So is this structure correct? Okay, one more thing we can do. So it is written that we have to write the name of monohydric alcohol. This is not a monohydric alcohol. These are the monohydric alcohols. Okay, see, these are the monohydric alcohol. Monohydric alcohol means one alcohol is present. Okay, so 2-methylphenol, 3-methylphenol, and 4-methylphenol. So orthocresol, metacresol, and paracresol. While separating a mixture of ortho and para nitrophenol by steam distillation, given the isomer, which will be steam volatile? Okay, which will be steam volatile. So about this, we have studied intermolecular and intramolecular hydrogen bonding. So ortho one shows the intramolecular and para nitrophenol shows the intermolecular. So since intermolecular is forming the para is forming the intermolecular hydrogen bonding, and intermolecular hydrogen bonding is stronger. So this will not be this will not be steam volatile, rather than ortho will be steam volatile. So intermolecular hydrogen bonding is present in orthonitrophenol, and para-nitrophenol methyls are strongly associated due to presence of intermolecular. Hence, ortho is steam volatile. See here, structure is given. The hydrogen bonding, intramolecular hydrogen bonding, and this is intermolecular between two molecules. Give the equation of reaction for the preparation of phenol for cumene. Phenol from cumene. So we have seen this. Okay, I'm not doing it again here. So first, reacting with O2, this will introduce two oxygens here, and further on hydrolysis, it gives us phenol. Write chemical reaction for the preparation of phenol from chlorobenzene. Preparation of what? Phenol from chlorobenzene. How you will do it? So we have to convert this chlorobenzene into phenol. So for that, so we have to convert this into this, right? So first we will try to remove this Cl. Okay, we will try to remove this Cl, because what we need here alcohol, OH group. Okay, any suggestions from your side? Just try it by yourself. I'm also saying what else can we do here. So suppose we convert this thing into diazonium chloride. So is it possible? First of all, you cannot do the SN substitution reaction, because chlorine does not give, so benzene does not give, haloalkane does not give this reaction, right? So this has a special name reaction, and its name is this. Okay, so we treat it with NaOH at high temperature and pressure, so that sodium phenoxide is formed, and at last we treat it with HCl. So this is a special type of reaction. Write the mechanism of hydration of ethene to ethanol. Simple. First of all, what will happen? The protonation of H2 will happen. H3O plus will be formed. This will be added. This H plus will be added here to alkene, and then H2 will attack, and this will result in this kind of structure. At last, this will be extracted, because this is just catalyzing the reaction, so H plus concentration is abstracted back. Next question, you are given benzene, conc H2SO4 and NaOH. Write the equation for preparation of phenol. So benzene we are given conc H2SO4, that is sulfonation. Then after sulfonation, we will treat it with NaOH, and that will result in phenol under high temperature and pressure. See, conc H2SO4 sulfonation, NaOH and heat, it will give you sodium phenoxide, and at last protonation. Show how you will synthesize 1-phenyl ethanol. So 1-phenyl ethanol from a suitable alkene. 1-phenyl ethanol, E2H5OH. Which, oh, this is benzene, your pH I am written it as PN, phenyl. Now what we have to do? We have to prepare this from a suitable alkene. So what can be the alkene? This alkene will be appropriate for the preparation. Next is cyclomethanol using an alkyl halide. Cyclomethanol, cyclomethanol. From what? Using an alkyl halide. So this alkyl halide we will use, and then we will do the SN2. What reagent can we use here? We can use alcoholic KOH, not alcoholic H, aqueous KOH. Pentane 1 all using suitable alkyl halide. Okay, pentane 1 all using suitable alkyl halide. So we can use this thing. Again, treat it with aqueous KOH, and this will give you reaction. See, this one we have done in this way only. Next is CH2Cl. We have treated with NaOH. You can treat it with KOH also. Similarly, treat this with KOH or NaOH. You will get your product. After that, give two reactions that show the acidic nature of phenol. Compare acidity of phenol with that of ethanol. So for that, we will treat it with NaOH, and base will just deprotonate the phenoxide and form the sodium phenoxide ion. As compared to this ethanol, phenol is more acidic because the negative charge on the oxygen is stabilized. See, phenol react with sodium to give sodium phenoxide with release liberating H2. This is one of the reaction. Next reaction is phenol react with sodium hydroxide to give sodium phenoxide. So this is the reason why our phenoxide ion is more stable, because the negative charge is being stabilized by the ring through resonance effect. Explain why is orthonitrophenol more acidic than orthomethoxyphenol. So orthonitrophenol we have OH here, nitro here. So this is orthonitrophenol, and this is orthomethoxyphenol. So suppose this is phenol, orthomethoxyphenol. So out of these two, which one will be more acidic? Say, so at first sight, you will say that this one is more acidic. Okay,